Hello everybody. So the next thing I'm going to be teaching you is how to solve systems of equations. Now a system of equations is something that occurs when you have more than one variable in a single set of equations that you're going to need to solve for. So you basically have more than one equation, you also have more than one variable. And this is something that's going to be really useful in real life because when you think about real world context, it's often that you have more than one thing to consider when you're trying to find out missing values. So for instance, when you're trying to create a budget and you're trying to figure out how much money you need to, survive on and pay towards bills, you usually have more than one bill. You might have rent, you might have car insurance, phone services. So there's like a lot of different things to consider. Let's say that you're running a business. Well, you have things to consider such as what is the price that I'm selling things at? What items am I selling? How many of them do I need? So there's really a ton of different ways you're going to think about using equations in real life, even when you're not considering how you are setting them up. So this is kind of the system behind doing that. Now, there are several different methods I'm going to teach you for how to solve these equations. And the very first method I'm going to teach you is called substitution. This is going to include something called the equal values method. Now, when we're going to be solving these, we've already talked about rewriting equations. You did the rewriting literal equations homework and lesson. And the substitution method basically makes use of that. It is used when one equation is already written with a variable isolated on one side of one or more given equation, or when you can easily use those rewriting equation skills to rewrite an equation in that way. So I'm giving you several different examples of how this could play out. Let's look at the most basic type of example that you're going to be getting, which is seen in example 1 here. Now, I'm going to make sure I can draw this really quick. There we go. So x equals 3y in the first equation, and in the second set of the equations here, it's 2x plus 4y equals 20. So when we're looking at a system of equations, we're basically saying that the numbers for x and y, the solutions, are going to be the exact same in both equations. So the values have to fit both equations. Now when we look at this, x equals 3y, 2x plus 4y equals 20, this very first equation already has x solved in terms of y. It says x is worth 3y. So when I look at this equation, I can plug where x goes, because it says x equals 3y, I can plug 3y in where x is, because x equals 3y. Okay. Then I've got 2 times 3y is 6y plus 4y equals 20. 6y plus 4y makes 10y. And I divide that by 10 on both sides. And I got y equals 20 divided by 10 is 2. Now what I can do is look at that first equation, x equals 3y. And since I know what y is now, I can plug what I just got for y into this equation. So x would be 3y, 3 times 2, 3 times 2 is 6. In my solution, I have to write it as an ordered pair, just like you would if you're graphing things. X comes first, x is 6. Y comes second, y is 2. So you'd have 6, 2 as your solution. X equals 6, y equals 2. If I wanted to check that, 2 times 6 is 12. Plus 4 times 2 is 8. 12 plus 8 is 20. So it fulfills the second equation as well. That's why it's a system. They have to both work. Now, another example of how one might use substitution can be found in this next system here. When I notice that the coefficient of one of my variables is 1, or maybe that it is divisible by both. Let's say this was a 2 here, right? And I add the 4b. I can divide both numbers by 2. It'll still work. what you want to do is rewrite this first equation to be solved for one of the variables, the easiest one. A is easy to solve for. It has no number in front of it, so I can just add the 4b to the other side and move it. So this would say A equals 4b plus 2. Or 2 plus 4b. It wouldn't really matter what order you put it in. It's the same answer. So I rewrite this one, then I can plug it into this one. So where A goes, I now plug that in. 4b plus 2 equals 18. I would distribute this. So 2 times 4b is 8b. And this is plus 3b. I forgot that. Don't forget what I just did there, because that was in the original equation too. See? It's plus 3b. So 2 times 4b is 8b. 2 times 2 is 4. And then we had the 3b from the original part of the equation. Equals 18. Now, when I look at this, I would have 8b plus 3b is 11b plus 4 plus 18. I'd have 14 over here because I'd subtract the 4 on both sides. 11b, and b would be 14 over 11. Sometimes you will get solutions like that. Now, when I look at that particular thing, what I could do if I wanted to is just plug that into a calculator and use decimals. Totally fine. You could use fractions too if you want to. Personally, in this particular case, I'd prefer a rounded decimal. And that would be 1.27 repeating, so that's about 1.3, we'll call it. Okay? And then I would just plug it in. Now, when you plug this b value in, you could plug it into this original one, you could plug it into this one, or you could put it into this one. It wouldn't really matter which one you put it into as long as you find A. So what I could do is say A equals 4b plus 2, which would equal 4 times 1.3 plus 2, and 4 times 1.3 is, I think it's 5.2. 1.3 times 4 makes, yes, 5.2. Plus 2, that's a 2, things spazzing out there, and that would equal 7.2. So my answer is, you can do A equals 7.2, B equals 1.3. You could put them in an ordered pair if you want to. It wouldn't really matter in this particular case, but just for sake of consistency, I will put 7.2 and 1.3 like that. Okay, and if I wanted to check that over, if I were to take 2 and times it by 7.2, I get about 14.4, and 3 times 1.3 would be about, let's say roughly 4. So it would be about 18.3, which checks out. It's close to 18. When you have a solution that close, we have the decimals, it would come out to be about equal. Just because we're rounding numbers, I rounded the 3 up. It would technically round down a bit. It would be equal to 18. When you use your calculator to check things like that, you can come up with approximate solutions. No big deal. Especially when you're having things where this wasn't really a whole number in the first place, it was rounded up. But yeah, that's the second way you could do that. If we have this here, I can rewrite it and then resolve it. Now, the last thing I'm going to show you is something called the equal values method. Now, this is only something that can work when you see equations written in either y equals mx plus b, or maybe x equals mx plus y, or my plus b. You know, like it's basically like you got one variable completely alone, and then the same exact variable completely alone between the two equations. And they often are written when you see slope-intercept form of an equation. If you remember, that's the y equals mx plus b, if you've heard of that or seen that one before. And the equal values method is actually a very simple way of solving equations without having to graph. I'm going to go ahead and use my text box for this guy. Now, the logic behind this is that you've already got the same variable with two different values. So when I look at this equation says y is equal to 3x plus 4, but this one says it's also then equal to negative 2x plus 19. So if y is equal to both these things must be equal to each other. That's called the transitive property. So what I can do is set those two things equal to each other in an equation, just because they're both equal to y. And I would get this. Now that is a heck of a lot easier to work with than is trying to rewrite things, then resubstitute, and just doing all this other work. Now when I look at this, I would want to move the 2x over here with the 3x. That would make 5x. And in order to make this equal out, I would then subtract the 4 to the other side. 19 minus 4 makes 15. And then I would divide by 5 on both sides, and I get x equals 3. And then I can just plug that x equals 3 into either one of these two equations. I'll just take the first one. So y equals 3x plus 4, and then that will equal y equals 3 times, and you just plug the number right in for the x, 3 plus 4. And that would be 9 plus 4, and that equals 13. So then my solution in this case would be 3, 13. And if I were to double check on both sides of these equations here, while I put it down here, I just realized my text box was going to be weird there. So if I double check that, I could also check in the second equation. It would work in the first equation. We proved that here. But then I plug a 3 in here. Negative 2 times 3 is negative 6. Now negative 6 plus 19 makes 13, which is equal to y. So the solution checks out. So solving systems of equations through substitution just means that you're plugging a known value in for the variable that is solved for into the second equation, solving for the remaining variable, then going back and using that solved value to find the other variable.